Hello everyone, welcome back to the course on electrical and electronics engineering. In this second section, we are going to see about applications of diode. In that, we will see the list of applications where we are going to focus on rectifier and clipper applications. Now let us learn the applications of PN junction diode. Ideal PN junction diode is a two-terminal polarity sensitive device. So it has a zero resistance in forward bias, that means diode conducts, and infinite resistance in reverse bias, that means that diode doesn't conduct. Due to these characteristics, there are a variety of applications. As a rectifier, it is used in DC power supply, as a switch in digital logic circuits which are used in computers, and clamping network, they are used as a DC restorer in TV receivers and voltage multipliers. And the clamping circuits, they are used as a wave shaping circuits in computers, radars, radio and TV receivers, and demodulation circuits. The same p-n junction diode but with a different doping concentration, they find special applications such as detector in optical communication circuits, the xenodiodes in voltage regulator, Varactor diode in tuning section of radio and TV receivers, LEDs, light emitting diodes in digital displays, laser diode in optical communication, and tunnel diodes as a relaxation oscillator in microwave frequencies. We are going to see two applications. One is the rectifiers as well as clipping circuits. Okay, first let us learn what is rectifier. Rectifier is a device, it's an electronic device used for converting AC voltage to DC voltage. So there are three types here. One is half wave rectifier. So here it converts AC voltage, this is AC voltage, right, input AC to pulsating DC using one half of the applied AC voltage. Okay, so the rectifying diode, here we use one diode. It will conduct during one half of the AC cycle only. So as you can see here, VA is the input to the primary of the transformer. From the transformer we get the AC supply is given to the transformer, so it is stepped down to a voltage so that the diode can withstand. So the AC voltage is given by Vm sin omega t. Okay, that Vm should be greater than the cutting voltage of the diode, Vr. So during the positive half cycle, what happens, anode, this anode will become positive with more positive with respect to cathode, so the diode is conducting. Okay, so we are able to get this positive half cycle of the input. For ideal diode, forward voltage drop is 0, so whole input voltage will appear across this load resistance. During the negative half cycle, the anode, what happens, anode becomes negative with respect to cathode, so diode doesn't conduct. So for ideal diode, the impedance offered by the diode is infinity, so the whole input voltage appears across the diode. So what happens, the voltage drop across this load resistance is going to be 0, so we won't get the negative half cycle, so we get only whenever the positive half comes, that is only rectified. So moving on, there is a full wave rectifier circuit with the center tap. So here it converts the AC voltage to pulsating DC, but it uses both the half cycles of the applied AC voltage, as you can see from this graph. So the complete AC cycle is rectified. Okay, it is both the half cycles are getting rectified here. It uses two diodes which conducts during one half of the cycle while other conducts during the other half cycle. So okay, you can see a center tap transformer is used here. During positive half cycle, the diode anode of this diode D1 become positive. Okay, but here this D2 become negative, so diode D1 only conducts. Okay, D2 doesn't conduct. So the load current flows through D1 and voltage drop will be equal to the input voltage. During the negative half, anode of D1 become negative, anode of D2 become positive. So the D1 doesn't conduct but D2 conducts. So the load current flows through the D2, and hence we are able to get the voltage drop that will be equal to the input voltage. So we are able to get the pulsating DC like this. So to eliminate the need of center tapped transformer in full wave rectifier, we are going for bridge rectifier circuit. So it is going to use 4 diodes instead of 2 diodes. So the 4 diodes are connected in the form of bridge. So you can see from this point it is dividing, and here it is getting meeting. Okay, so the AC input voltage, how we are applying? We are applying between the diagonally opposite ends of the bridge. Diagonal opposite ends of the bridge, we are applying the AC voltage. The load resistance is connected between the other two ends of the bridge, right? Now let us understand the different types of clippers. So this is one of the application of PN junction diode, where in a positive clipper, if you see, when we give the input sinusoidal voltage, we are able to see that positive portion of the cycle is getting clipped off. So you have to connect a diode in such a way that whenever we give the input, okay, so for a positive clipper, it is input is given to the negative terminal of the diode, so that it allows only diode conducts only negative half cycle, but it will clip off the positive half cycle. Next, coming to the negative clipper, we have to connect a diode in such a way that input is given to the positive terminal of your diode, that is anode part. So if you give the signal to the anode part of the diode, so it conducts only the positive part, but negative portion is getting clipped off. In some applications, it is required to remove a portion of positive or a negative half cycle. Previously, we saw completely positive half is clipped, or else negative portion is clipped. Now, we need to remove only a portion. So, in such case, we need biased clippers. So, there are two types. One is biased positive clipper and biased negative. In biased positive clipper, the circuit remains same. Okay, the input is given to the cathode part, because only it will conduct the negative portion of your AC input, but we are going to connect across the load resistor one voltage source VR reference voltage we are going to connect. So the output will be conducted, the positive portion will be allowed to go through until the input voltage is less than this VR. Okay, until that it will conduct the positive part also. Only above that it is getting clipped off. Similarly, in bias negative clipper, so we are connecting the diode in such a way that input is given to the anode part of your diode. Okay, so that it conducts positive half cycle fully, but we are going to have a small portion of negative half cycle. So when the input voltage is less than minus VR, the diode doesn't conduct. Okay, and the clipping is going to take place, but the input is greater than minus VR means the diode will conduct that negative half cycle. So these are the applications of PN junction diode. First we saw about rectifiers. One is half wave rectifier, full wave rectifier and bridge rectifiers. Then we saw about clippers. In that positive, negative and bias positive clipper and bias negative clipper.